Hey guys, it's the Circuit Hadron Video Podcast, and today I'm going to be talking about the launchpad. Just real simple intro video, nothing complicated or anything like that. So, for those of you that don't know, the launchpad it used to be at least $4.30. I don't know if they've changed the price since the year ago or maybe 6 months ago when I bought it. I don't really know. So anyway, what it is it's sort of like an Arduino. I'm sure you know about an Arduino. Like, you have the Duo Milanova here. I have an LCD on top of it, but it's like that. It's a microcontroller prototyping system essentially. What you got here is you have a FET, F-E-T, an emulator basically that connects USB to the chip, so you can program it. And then if you want to, just use this part of the board on its own, you can just unplug these things, and it's not connected to the FET anymore. It runs on a 32.8 something kilohertz crystal, which I have not settled down here. And it's really simple. You can upgrade the chip size to get more pins, and also to get like capacitive touch sensing and stuff. It's pretty nice, and it's for $4.30. Even picking one up, if you're not going to use it, it won't hurt you in the least bit. It's like $10 with shipping. Really cheap, right? You can, if you just want to make something blinky, you can do it easily without worrying about money. So it has a built-in button and 2 built-in LEDs. Now, I'm sure some of you are going to be wondering this question is, how do you make one pin high? It's not like on Arduino where you just say, pin 4, like LED equals, 3, pin mode LED equals to output, which would then make your program know that it's going to be outputting to pin 3, which it thinks is called an LED. So anyway, if you want to put just pin 1.0, this second pin on the chip here. Oh, the camera's giving a shadow. Anyways, the second pin on the chip in the header pin 1.0, which is what the first LED here is connected to on the board. You can also remove the LEDs by taking these off. You would type in 0x01 for the hex value, or the binary value 000000001. Now, I'm sure you can start to see a pattern in just a sec. And then to put just pin 1.1, you're going to hit 0x02, and that's going to be 000000010. Okay? And then you're going to think it's pin 03, but it's 0x04. So, as you can see, it's for 1.0 it's 0x01, for 1.1 it's 0x02, 1.2 is 0x04, 1.3 is 0x08, 1.4 is 0x10, 1.5 is 0x20, and 1.6 is 0x40, and 1.7 is 0x80. Now, if you look at the corresponding binary values, which I have here, you'll notice that there's a pattern going on. 0x01 has a 1 at the very end. 0x02 has the 1 second to the end. 0x04 has the 1 third to the end. 0x08 has the 1 fourth to the end. So as you can see, it's just the way it works is that each pin, pin 1.0 all the way through pin 1.7 are assigned each of the places. So if on your binary, you have 8 digits, right? You have 1 place, 2 places, 3 places, 4 places, 5 places, 6 places, 7 places, and 8 places. Each of these places, from left to right, is sort of the pin is assigned to one of those places. It would be 1.0, 1.1, 1.2, 4, 1.5, 1.6, and 1.7. Okay. So then, if you were to make this one, if the binary value in that place is assigned to 0, that pin will be low. If the binary value in that place is assigned to 1, it'll be high. So that's why you sort of see this that pattern going on there, is that you have 1, then 1 second to the last, so on, right? So, that's sort of the way it works. So if you wanted to put all of them on, you'd hit 0xFF, and you can look at a binary chart. But essentially, if there's a 1 in the place where the pin is assigned, if you were to take the hex value, right, take any random hex value, convert it to binary using one of the converter charts, right? I have a little long one right there. Anyway, if you were to take this take a hex value that, convert it to binary. If there's a 0 in the place, that pin is low. If there's a 1 in the place, that pin is high. Low means 0 volts, high means 3.3 volts, which this thing works at. So, and if you want to do it vice versa, and if you want pins 1.4 and 1.1 to be high, you simply skim a binary chart, figure out where only 1.4, where only this place and this place have a 1 and all other places have a 0, and then convert that to hex. So that's what you would do to get specific pins to go high and other specific pins to go low. So keep in mind, so if we have the value, 0, 0, 1, 0, 0, 0, 0, 1, then we would have pin 1.5 being at 3.3 volts, and pin 1.0 being at 3.3 volts, and the rest of them being at 0 volts. So now if we were to go convert that, we have a 1, 2 for me, and a 1 all the way down. So a 1, 2 for me, and this might take a while, but okay, wait. Oh, no, this might take a while. 1, 2, 3, 4, 5, 6. Alright, this is the start of the 7s, so let's have it like... There we go. 0x41. The reason that works is because you see this only has 7 digits listed. 1, 0, 0, 0, 0, 1, right? That's 7. So in the front there would automatically be a 0. That's 0x41. Okay? So, that's how it would work. Those are the places. So, really not that difficult to use a launchpad to get specific pins to do specific things. Alright, thanks for watching.